Alright, welcome to part 2 of rational expressions. Let's first look at how to multiply and divide rational expressions. Alright, and it's a lot like simplifying, just with a few more factors. Alright, remember when you multiply with cross, factor, find domain, then cancel. Alright, for these problems, you never really want to be expanding out polynomials, binomials. You want to factor, right? Expanding it is kind of going in the opposite direction. What I mean by expanding it is like foiling, right? If you see like x minus 2 times x plus 3, don't FOIL that out. Leave that factored. You want to get everything as factored as possible so you can find common factors and cancel out, all right? If you're dividing, remember division is just the same thing as flipping and multiplying, all right? Multiplying by a reciprocal. So when dividing two fractions, don't ask why, just flip and multiply. All right, someone once told me that and it stuck, and that can help you remember. Right, like dividing by 2 is the same thing as multiplying by 1/2, right, the reciprocal of 2. All right, we can use that to our advantage when simplifying rational expressions. All right, so here's the first one. We'll simplify this. So we're going to factor everything. We're not going to multiply out like a minus 4 times a squared plus 5a plus 4. We're going to factor everything. All right, so our first factor is a minus 4. All right, and then we're going to multiply across. So this a squared plus 5a plus 4, that's going to factor to a plus 4 times a plus 1. All right, and then over this a squared minus 16, we could factor that. Be a minus 4 times a plus 4. And then times a minus 5. So see, I didn't expand, I didn't cross multiply. All right, cross multiplying is only something you do when there's an equal sign. All right, if you had like a over b is equal to c over d, all right, because there's an equal sign, that would be the same thing as AD is equal to BC. All right, now if you're multiplying across, which is what we're doing right now, then you multiply across. You don't cross multiply, only when there's an equal sign. All right. So now back to our original example. Let me get rid of that white stuff. Now we're going to cancel, but before we cancel, we factored. Now we're going to find the domain. So we're going to say a cannot equal 4, negative 4, or 5. All right, because those are the x values that would make your denominator 0. Now we cancel. So cancel out this a plus 4s, cancel out these a minus 4s, and you get a plus 1 over a minus 5, where a cannot equal 4, negative 4, or 5. Alright? And that is our final answer. I don't know what this thing's doing here. You can ignore that. I guess I could erase it. But that's it. Alright? That means if you wanted to, see what this original function would equal if you plugged in 10 for a. Alright, it might be easier to just do all this factoring and canceling and then just plug 10 into the simplified version. That's what it means to simplify something. You're making something more complicated simple. And as long as you don't plug in any of these domain restrictions, you'll get the same answer. Alright, and if you plugged in 4, negative 4, or 5 into the original function, you would get undefined. Alright, and you would here because of these domain restrictions. Alright, let's try now. We have a division problem. So we're going to flip and multiply. Alright, but first, I still say we factor everything. So starting off with 5x minus 9, that can't be factored, that's linear. Alright, for this denominator in the first fraction, 42x cubed minus 48x squared, 6 and x squared go into both of those terms. So we could pull that out. And we're left with a 7x minus 8. Alright, and then divided by, now in this numerator, we could pull out a 9x. Alright, and we'd be left with 5x minus 9. And then in the denominator, alright, that would be an AC method problem. Alright, so we're going to factor 7x squared plus 27x minus 40, we're going to take AC, which is 7 times negative 40, and you get negative 280, and you're looking for two numbers that multiply to negative 280, but then also add to 27. Alright, so if you start listing all the numbers that multiply to negative 280, you might get like 1 and negative 280, 2 and negative 140. Right? I paused and cheated, and I found that negative 8 and 35 would do it. Alright, so negative 8 times 35 is negative 280, and negative 8 plus 35 is going to be 27. So now we can, let me just erase this down here, we can take this function, this quadratic, and then break up that middle term, 27x, as, oh man, what the heck, 35x minus 8x minus 40, and then factor by grouping. So you can pull out a 7x in the first two terms, and you're left with x plus 5, and then pull out a negative 8 here, and you're left with x plus 5. And then pull out an x plus 5, and you're left with 7x minus 8. Right, and that's going to go right here. X plus 5 times 7x minus 8. Alright, now we're going to flip and multiply and then cancel. But before we do that, we have to take care of our domain restrictions. So the zeros of our denominator, starting with 6x squared right here, would be 0, and then 8/7, then also negative 5, and then 8/7. But also, we have to take out 0 and 9/5, because those are the zeros of this numerator, which is, this entire fraction is actually like a denominator because we're dividing the first rational function by it. So when you're dividing two rational functions and you're looking at domain, you want to take out the zeros of both numerators. So look at the zeros of here, and also the denominator of the fraction getting divided, because it is a denominator. Alright, so this would be our domain restrictions right here. Now we're going to flip and multiply. So to do that, I need to make some room. So how am I going to do that? I'm going to erase all this here. I'm going to make this bigger. Nice. Alright, made the eraser bigger. Alright, going to erase all that. Now, I'm just going to take this, get rid of the division sign, and then multiply by its reciprocal. So it'd be times x plus 5, 7x minus 8, over 9x times 5x minus 9. Alright, so ignore this, and this right here is still in our numerator. 6x squared times 7x minus 8 is still in our denominator, and we have one big rational expression. Alright, so now we could cancel. We could take out these factors of 7x minus 8 and cancel out these factors of 5x minus 9. Alright, and you'd be left with x plus 5 over 6x squared times 9x, which would be 54x cubed. Alright, and then with these domain restrictions still. Alright, so if you plug any x value into this simplified version, as long as it's not a domain restriction, you'd get the same value as if you plug it into that one up there. Alright, and that's what it means to simplify these things. Alright. Adding and subtracting rational expressions. I could probably make a whole nother video on this. And you know what? I will, because we'll probably spend a whole day just on this. So let me end it here. Thanks for watching, and see you in class.